coordinate geometry 5. So we need to take a look at the slope of these distance time graphs, and we'll find that the slope of the line will equal the speed that the object is travelling at. So first off, speed equals slope. And if we look at these, the blue line has the smallest slope, the green line is a larger slope, and the red line is a much larger slope. And what that means is the speed of the red one is much higher than the other two. So in terms of lowest speed, blue is the lowest speed, green is the next lowest, and red is the highest. Okay, how about in this case? Which has the greatest speed? Well, ask yourself, which one has the greatest slope? Is it the red or the blue? The blue has the greater slope, so as a result, the blue has the greater speed. So we know that the red line from 0 to 4 has a slower speed than the blue line, or the blue object. And then we also know that there's a horizontal portion there just below the stationary text. And what that means is the red has stopped, its slope is equal to 0, therefore its speed is equal to 0. So slope equals speed. And here are some examples of different slopes, and I'm just going to go through how they relate to the speed. So A, horizontal line, 0 slope, 0 speed. B, slope is positive, speed is positive. So that means that as the time goes by, the distance increases. C, slope is negative, we say the speed is negative in that case then as well. Okay, if we compare B and F together, so the slope of B is larger than the slope of F, so that means that B is travelling at a faster speed. Now what we'll notice here, and the last thing that's probably standing out for you, is what's happening with D and E. Well, those guys aren't straight lines at all. So as a result, these are objects that are moving without constant speed. So for D, the speed is increasing as time goes by. That's actually an acceleration. And with E, the speed is decreasing as time goes by. That's a deceleration. Right now, I'm not too worried about the two of those, but it's nice to see that D is an acceleration and E is a deceleration. Okay, second way to describe these and to describe all graphs. Look at the x-axis and look at the y-axis. And the description starts with how the x-axis changes, and then tell me what happens to the y-axis. So listen to this. For graph A, as time goes by, the distance stays the same. So as time goes by, the distance stays the same. Look at graph B. As time goes by, the distance increases. And that's the line going from the bottom left to the top right. And as time goes by, the distance increases. That means that the speed is a positive speed. If you look at C, as time goes by and we read from left to right, the distance decreases. So as time goes by, the distance decreases. That corresponds to a negative speed. And F, as time goes by and we read from left to right, the distance increases as well, meaning we've got a positive slope and a positive speed. So those are two ways to talk about distance time graphs, directly via the speed or via the axis, and both are required interpretations for you. So let's look at this and we'll have a look at it in terms of both interpretations. First of all, the slopes. The slope of A and C, both positive. The slope of D, negative. The slope of B, 0. So in terms of speeds, A and C, positive speeds, D, negative speeds. Compare the slopes of A and C. The slope of C is larger, meaning that the speed in that portion of time is larger when compared with A. Okay, now let's have a look at it in terms of the axis. Let's start with A and we're reading from left to right. So A, as time goes by, the distance increases. That means that the person is going further and further away from where they started from. Look at B. As time goes by, between 11 and 12, the distance stays the same. That means the person is stopped. Let's have a look at C. As time goes by, between 12 and 12:30, the distance increases. So the person is going further away from where he was. And then finally, when we look at D, from 12:30 to 2 o'clock, the person's distance is decreasing. In other words, they're going back home. So the journey described in total would be, if you started from home, you walk away from home for 2 hours, you then stop for an hour, you walk further away from home for half an hour, and then over the next hour and a half, you're in section D, so you travel back home for the next hour and a half.